Question 12. We want to find the solution of the second order differential equation d2y by dx squared plus 3dy dx minus 4y equals e to the x. And this is subject to the initial conditions that when x is 0, y is 0, and when x is 0, dy by dx is 0. So first thing we're going to do is find the complementary function. And to do this, we're going to use the auxiliary function. So the auxiliary equation, and that is going to be lambda squared, plus 3 lambda minus 4 equals 0. So lambda squared has come from this bit, 3 is over here, and then negative 4 is the y. Got that out. So let's find the roots of this equation here. So we can factorize it nice and simply. Lambda plus 4 and lambda minus 1. So therefore we know that lambda is 1 and negative 4. So this gives us the first part. This gives us our complementary function, which is some constant e to the x plus some other constant e to the negative 4x. Do that again, negative 4x. Okay. And we know that our function y is equal to the complementary function plus our particular function. So how do we work out what this yp is? So yp is all related to our e to the x here. So if we assume that we can say yp is alpha, some constant alpha, multiplied by x e to the x, then we can find out what alpha is. So let's say that the first derivative of this, let's differentiate it using the chain product rule, that'll give us alpha e to the x plus alpha x e to the x, and the second derivative will give us 2 alpha e to the x plus alpha x e to the x. If we now substitute this into our original second order differential equation, so y double prime is d2y by dx squared, so we're going to have 2 alpha e to the x plus alpha x e to the x, and then we're going to have plus 3 lots of y prime, so dy by dx, which is alpha e to the x plus 3 alpha x e to the x, and then we want to take away 4 lots of y, which is our alpha x e to the x. Oops, try to do that up. And that is equal to e to the x, our right hand side over here. So if we just collect like terms, 2 alpha, 3 alpha, so it's 5 alpha e to the x plus 4 alpha x e to the x minus 4 alpha x e to the x equals e to the x. So 5 alpha e to the x is equal to e to the x. So this tells us that 5 alpha equals 1, alpha equals a fifth. So we now have that our particular integral yp is equal to a fifth. Let's write this over here. Yp equals a fifth x e to the x. So now we can write our solution, which says that y equals a e to the x plus b e to the negative 4x plus 1/5 x e to the x. So we have our complementary function here, over here, and then our particular integral from there. But we're not done. So what we need to do now is, using our initial conditions, we want to find out what capital A and capital B are. So let's write them down here. We're going to have y of 0 equals 0 and y prime of 0 equals 0. And our function is y equals a e to the x plus b to the negative 4x plus a fifth x e to the x. Okay, so what we're going to do is we are going to differentiate our solution here. So y prime is equal to a e to the x, just goes to a e to the x. B e to the negative 4x goes to negative 4 b e to the negative 4x. And of course we can do the same here, so a fifth e to the x plus a fifth x e to the x. So now we can put in our initial conditions. So y of 0 is 0. So let's put 0 in here. So y of 0 is equal to a plus b plus 0. We don't need that. And then y prime of 0 is also equal to 0. Oops. That one's equal to 0. So y prime is a minus 4b plus a fifth. That equals 0. So now we just need to solve these two using simultaneous equations. We've got two equations and two unknowns, so we can find out what a and b are. So we know that a equals negative b. Substitute this in, that is equal to negative 5b plus a fifth equals 0, which implies that a fifth equals 5b, which implies that b equals 1 over 25. We know that a is equal to negative b, so we can now say that a equals negative 1 over 25. And we finally have a value for a and b, so we can write our final solution. So we're going to use this and just substitute in what a and b is. So y equals 1/25 e to the negative 4x minus 25th e to the x plus 1/5 x e to the x. And that is the solution of the differential equation using the initial values. Thank you for watching.